All right, so in this video, we're going to talk about multiplicity of zeros. And so over here, I wrote down the definition. A multiplicity of zeros is how often a zero occurs. And let's just take a look at this example right here. Notice this example is in factored form. And so the key is that all your multiplicities can be found, or the zeros, multiplicity of the zeros can be found when it's in factored form. Now, there is one piece of information that you need to be aware of. These guys all have to be linear factors, right? This is linear, this is linear. This guy right here is linear, okay? If I put a parentheses around here, that's also linear. Now, this guy right here is not linear, right? And so you can't determine the multiplicity of what just straight from this function right here. What I'm going to have to do is do a little factoring first. And even though this is not a pattern of difference of two squares, you can factor it over irrationals, which we'll cover in a future video or lesson. So you could factor this as x plus root 5 times x minus root 5. Okay, so now everything is linear. All your factors are linear. And if I just want to find the zeros of this function, right, I simply set f of x equal to 0. And so just do some mental math over here. If you calculate the zeros over here, this, if you set negative x cubed equal to 0, you're just going to get 0. If you set x plus root 5 equal to 0 and you solve for x, you're going to get negative root 5. Positive root 5 over here, negative 3 over here, and then positive 4. Okay, so these are all the zeros. Again, make sure you look at the vocabulary of what a zero is, right? A zero is an x-intercept, it's a solution, it's a root, it's where the graph touches the x-axis. Okay, so all we're concerned about for multiplicity is how many times does that zero occur, right? So I'm going to abbreviate mult. And the way I figure out the multiplicity of this zero of 0, I look at the exponent, right? This exponent right here is a 3, and so the multiplicity of that 0 is just 3, and so forth, right? If I look at the 0 for negative root 5, to determine the multiplicity, I look at the exponent right here, it's just 1, so that multiplicity is 1. If I look at the multiplicity of the positive root 5 for this 0 right here, right, the multiplicity is also 1. And then so forth, right? The multiplicity of negative 3, in other words, how many times does that negative 3 occurs? I look at the exponent, it has to be a linear factor. That's also 1, right? And then multiplicity of this 0 of 4 is just 2. Okay, so that's what multiplicities are. It just determines how many times a 0 occurs. But more importantly, the multiplicity tells you what is happening at the x-axis when you sketch it, okay? So over here, zeros with an even multiplicity they bounce at the x-axis. Okay, so in other words, if I give you a function like this, f of x is equal to x minus 2 squared, and I were to sketch x minus 2, right, squared, the 0 at 2 over here, the 0 would be 2. The multiplicity is 2. Notice it bounces at x is equal to 2. Okay? So zeros of an even multiplicity bounce at the x-axis. Zeros with a multiplicity of 1 crosses at the x-axis. Okay, so let me just give you a quick example of that. Of x is equal to negative x plus 3 times x minus 2. If I were to ask you to calculate the zeros really quickly, you would say, Mrs. Zhu, the zeros are negative 3 and 2. And notice the multiplicities, right, are 1. The mults are 1. And so if I were to sketch this, right, this is just a parabola right here. Here's negative 3, here's 2. Remember, this parabola is going down, intercept form. I don't care about the vertex right now. I just want to show you that it crosses. It crosses. Okay, so the last example, and really this is just me using a terminology here. I'll show you in a second. Zeros with an odd multiplicity of 3 or higher. In other words, 3, 5, 7, 9, 11, 13, etc. It still crosses, but the terminology I like to use is flexes at the x-axis. All right, so a quick example would be something like this. F of x is equal to x plus 1 cubed. If you were to calculate the 0 really quickly, you're going to get a 0, negative 1. You can clearly tell that the multiplicity is 3, right? And so this is just your x cubed function, right? Shifted 1 to the left. And a flex kind of looks like a cross, right? But it kind of hugs the x-axis. So what I like to call that is a flex. Okay, so you could think of it as still crossing, but it's flexing. And that's what multiplicities do. They determine the behavior of your zeros at the x-axis. And you'll get a lot of practice in these next couple examples.